Okay, guys, so I want to talk about the life cycle of a star. So, welcome to week one of our super fun online learning journey. We're still going to learn about stars today. So, let's talk about the life cycle of a star. So, basically, we're going to learn about the life cycle of two types of stars. We're going to learn about the life cycle of low mass stars and high mass stars. They're similar, but not exactly the same. So, the first thing you need to understand is that a star is kind of like a living thing or a person in that it goes through different stages of its life. So stars kind of start off as young baby stars and then they evolve into grown stars and then eventually they die. So we're going to start by talking about the low mass star. We're going to start with this part right here. This is the nebula or the protostar. So what we're looking at in a nebula is basically a cloud in space of gas and dust. We have basically hydrogen gas, and our dust is going to be carbon or silicon. And what happens is that dust and gas collects in clouds, and it continues to collect and collect and collect until gravity begins to pull that dust and cloud together. So that is what we call a protostar. So we have gravity pulls together. Okay, so as gravity pulls the dust and gas together, it's kind of like a snowball, right? You keep packing on dust and gas, and the gravity is going to get higher and higher, and the density or the mass of that star is going to get higher and higher. When we reach a point where that gravity causes the temperature of the star to increase, we end up with our protostar. So when we have our protostar, we have fusion beginning. Sorry. So fusion begins, and what we have is those hydrogen gases are going to start fusing into helium gas. Okay? Helium gas. And when fusion happens, we become a real star. And when we become a real star, we're going to go up here to this main sequence star. So as fusion is happening between the hydrogen atoms fusing into helium gas, we have a main sequence star. A star spends most of its life in this phase. So most of life here. For a low mass star, we're talking 80 to 100 billion years. 80 to 100 billion years. Okay, at this point, the star is at equilibrium. The rate of fusion is occurring, but there is enough hydrogen gas that the star continues to fuse, continues to fuse, continues to fuse. Now, when that hydrogen gas begins to run out, we begin to fuse helium. So when fuel begins to run out, and when I say fuel, I mean hydrogen. When the fuel begins to run out, the star begins to expand. The gases around the outer area of the star begin to expand. And then when the fuel is completely run out, the core of the star will contract. So what happens is when fuel completely runs out, when the fuel runs out, the core will shrink. And when the core shrinks, we can end up back with a planetary nebula. So basically, there is no more hydrogen and helium to fuel, and the star turns back into a nebula of gas and dust right here. And then we're going to have our last two phases. So we have a neutron star, and a neutron star is basically, oh, I'm sorry, not a neutron star, a white dwarf. A white dwarf is basically going to be when the star is out of fuel So it's basically going to be a dead star. Now, at this point, the star can completely die, or that nebula can form a new star. So it's a cycle, as you can see on the low mass side. Okay, now we're going to talk about the high mass stars. So high mass stars are much bigger than our sun. Okay, so a high mass star, we're talking 10 times bigger than the sun. So those are really, really big. So when we have a high mass star, we're going to start with the same process. We have hydrogen gas, carbon and silicon dust, gravity pulling it together, and fusion beginning. Okay, once fusion begins and we get our main sequence star, we're looking at about 20 million years. 20 million years for that star to stay as a main sequence. As fuel begins to run out, lovely interruption. Okay, as fuel begins to run out, we're going to get our red supergiant. Again, the outer layers of gas on that star are going to expand as fuel runs out. When the fuel for the star completely runs out, so there's no more fuel, the gravity can no longer hold the star together. So gravity can no longer hold. I'm going to write that. Gravity cannot hold. So the star basically explodes into a supernova. Explodes. All the mass that was in that star, all the dust and all the gas is going to explode outward in a very bright explosion called a supernova. At this point, the core collapses. The core collapses and we end up with a neutron star. The neutron star is going to have a lot of gravity. It's going to be very, very dense. It's called a neutron star because the protons and the electrons inside the atoms are pushed together with so much gravity that they actually turn into neutrons. Okay, so we're talking about a massively humongous amount of gravity pushing those atoms together. Okay, we can also get a black hole. A black hole is a collapsed massive star, so it's completely collapsed. There is a lot of gravity. And its gravitational pull is so great that even light can't escape. Okay, so the black hole is kind of our version, our dead version of the high mass star. Okay, so I hope that this quick video helps you guys understand the life cycle of a star better. Please don't do the life cycle of a star task card questions until you have viewed this video. I don't want you guys to go on there and guess. I don't want you to Google or Siri the answers. I want you to look at this and understand it. Okay, I will talk to you guys soon. I love you. I miss you. Good luck.